Okay guys, so a leakage test was conducted to determine the effectiveness of a seal designed to keep the inside of a plug airtight. An air needle was inserted into the plug, and the plug and needle were placed under water. The pressure was then increased until leakage was observed. Let X equal the pressure in pounds per square inch, and assume that the distribution is normal with mu and variance sigma squared. And the following n numbers is equal to 10. So what we have right here. So part A, part B, and part C. So final point estimate for mu and for sigma, and then 95% confidence one-sided. So we need to start first with, you see again, in other videos I've mentioned, when you don't have mu or in sigma, or when you don't have sigma, you have to use the t-test. So our formula here is going to be x bar plus or minus t of alpha over 2 and times the square root of, nope, not the square root of, but my bad, times sigma over the square root of n. Okay, so x bar is 1 over n, so 1 over 10, times the summation of our xi, I equals to 1, all the way to n. And so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 out of 10, and when we add, so 1 over 10, and times, when you add 3.1, plus plus 3.3, so this 3.1 plus everything else all the way to 3.3, you would get a x bar of 3.58. So this is your x bar, and this is for the sample. So the sample x bar is 3.58. Now when you do, after you do that, this is your point estimate for mu. Now part B, point estimate for sigma, we know that sigma is equal to the square root of 1 over n minus 1 times the summation of x minus x bar squared. And sigma there would be equal to 1 over 9, square root of 1 over 9, times the x, which is the summation of, so let me put that actually in a better place. Let's see this. Okay, so that would be 1 over 9 times the summation of 3.1 minus 3.58 squared plus plus the last one, 3.3 minus 3.58 squared, and that would equal to 0.5112. Now we have both the point estimate for mu and the point estimate for sigma. How do you calculate t of alpha over 2? Let's go to our thing now, and so we go to our and this is for strictly, this is only for TI89 titanium. Don't forget that. You go to your catalog and you click on F3, and you will click on inverse T, and you will see area on the bottom and df, which means degrees of freedom. So the area is because they asked for the 95%, and I've showed you guys before how to find the area when you're doing this. don't forget you have to do 1 minus the confidence interval and divide by 2. Then you put that as your area. So 0.025 degrees of freedom is 9 because you have 10 numbers. So the degrees of freedom is n minus m degrees of freedom. So you have 10, and we're only using one variable, which is x, so it's 10 minus 1. And there you have the answer, which is 2.26. So 2.26. So that means we're going to have 3.58 plus 2.26 times sigma, which is 0.5112, divided by square root of n, which is square root of 10. And let's see what that equals to. So 3.58 plus 2.26 times 0.512 divided by square root of 10. Nope. And that's equal to 3.945. So 3.95946 then. So that will go to, now it's gonna be interesting. Here it says that, don't forget that part. Here it says that 595 one started confidence interval for mu, that is an upper. So don't forget that upper bound for mu. So that means the lower bound is going to be, will start from negative infinity, and the upper bound for mu will finish at 3.95. So 3.95946. And the idea, guys, is not that to get the calculation right, but once you understand the context, then you can do it. So if this is I made some mistake in the calculation, that's not fine, but that's not the main reason. So I want you guys to understand the context and how to do it. So this is this one. That's how you do it, and sort of pretty easy, but it might be tedious sometimes. But so guys, I hope you understand it, and thank you for watching the video, and I will see you next time. Have a good day. Bye.